Very excited to be here. I'm Anupam Datta. I'm an AI research lead at Snowflake and formerly a professor at Carnegie Mellon University and co-founder of Truera, which Snowflake acquired last year. With me is a very distinguished panel here today. Dawn Song is professor at UC Berkeley, a serial entrepreneur. She's been doing exciting work with building an agents community and is also co-founder of Virtue AI, a startup that's doing exciting work with agents and security. Graham Neubig is a professor at Carnegie Mellon University, co-founder and CEO of All Hands AI, which is a coding agent startup that's got tremendous adoption in the community. Next up is Matt Fredrikson. Matt is an associate professor at CMU, long-term collaborator. And recently, he started a company called Swan AI, which is working on AI security and safety, working with all the frontier labs, OpenAI, Anthropic, DeepMind, and so on. And finally, Aditya Parameswaran. Aditya is a professor at Berkeley, working, among lots of other things, on data agents. And his first company was acquired by Snowflake about a year and a half ago. So you have a good mix of folks who have gone from doing fundamental research a lot around agents recently to building community, open source projects, and frontier startups that are taking research into practice. And it's really exciting to have this group here. So we'll touch on a few different areas related to building an agentic future. Let me start with Dawn. With agents starting to get a good amount of traction and adoption now, one of the big questions that we hear always is, how do we trust these agents? What are some of the kinds of risks that we have to guard against from a safety, security consideration? And that's a big area of expertise for you, and you have done some pioneering work in this area. Would love to get your take as we kick off.
Great. Thanks a lot for having me here. Really glad to be here. So talking about safety and security issues and risks for agents, this actually is a very broad topic. There are many different types of AI safety and security issues with agents. So first we can start from something even, a little simpler, just these large language models, which the agents are built on top of. So first, when we talk about large language models, already there's a lot of safety, security issues. So recently, led by Joshua Bengio, and together with other hundreds leading AI researchers from 30 countries, we actually released reports, international AI safety reports. This is the first report that actually brings together the community with such large-scale international collaborations, really listing out the broad spectrum of different types of AI safety and security risks in the space. Largely speaking, we list out like 3 main categories. One is malfunction. For example, has a lot of issues of hallucination, and also can have toxicity, have various bias, has various issues that can lead, when using applications, can lead into like a malfunction type of risks. Another big category is misuse. So for example, LLM is really powerful, and when used in agents and application settings, then this can enable like malicious attackers to also misuse the capabilities. And from what we have seen, I think many people here have already experienced phishing attacks, social engineering attacks. These type of Gen AI capabilities can significantly increase the essentially the power capabilities for malicious attackers to make their job a lot easier for creating and launching these type of attacks. And then overall, there's also systemic risks and so on as well. That's even larger topic.
Thanks, Dawn. So there are a couple of dimensions that you highlighted around agents themselves having a broader attack surface now, because the other thing is we are seeing distributed agents with MCP and agent-to-agent protocols increasingly getting adoption, which means that even from inside of trusted systems, we might be able to calling out to tools where attackers might have greater control over what inputs to supply. So it's going to get very exciting and important over the next year or two to really secure our agents. And we'll circle back to you in a little bit and hear more about what you're doing at Virtue AI. But transitioning to you, Graham, coding agents are having their moment this year. Windsurf is just getting acquired for $3 billion, and our AnySphere and Cursor is getting huge adoption, getting to like a $10 billion valuation from what we hear. And then we have All Hands that you have been driving with a tremendous community around it. What are some of the key themes that you're seeing on the research and technology side that we need to push more to really get even broader usefulness out of coding agents? What's on your mind these days?
Yeah, so one of the great things about building, a practical system that lots of people are using is I get the best research ideas too. So you kind of get to double dip there. But basically the vision is that regardless of what you're building or what code base you're dealing with, whether it's a small code base, front end code, whatever else, a large messy enterprise code base, or things like this. No matter what kind of task you want to do, whether it's implementing new code, fixing failing tests, fixing merge requests, researching a new idea and being able to insert it into your existing large code base or something like this. All of these things should be possible, and somebody should be able to dispatch it to an agent with confidence, knowing that either the agent will solve it for you, or if they're not going to solve it for you, they're not going to leave you with a huge mess in your code base. And so that's the problem we're trying to solve. There's a lot of issues that you need to do with this. The first thing is kind of base agent accuracy needs to be very good. When you're dealing with smaller code bases or simple tasks, it's relatively easy to do this sort of thing. When you're dealing with much larger code bases or more complex debugging tasks, it's a lot harder. And I think that's the part where we're working on right now. There's a number of different ways you can do this. You can do this by having better understanding of the code base, by going through the code base, organizing it, giving instructions about how you should work in the code base, better localization of files, which files you should be editing, and things like this. Also, there's a lot of work that has been done, a lot of more work that needs to be done on the foundation model side. And some requirements for good foundation models for coding are being able to write code, of course, but also being able to run code, understand error messages, figure out what's going wrong when things are going on there. And I think a lot of the foundation model companies are doing this sort of thing behind the scenes. I would like to point out one research work that we've done recently, which is called SWEGEM, which is a reinforcement learning environment that demonstrates how you can actually train these models. And we did this open source and released OpenHandsLM, which is our language model. And then together with Mistral, the foundation model company, we released something called DevStrol, which does this. And so we shed a little bit of light into how to do this, and we released the best open source coding model together with this. Separately from this, I think the base link capability is important, but separately we need to have an idea about when the model doesn't know what to do, when the model is not confident, will it go and do a bunch of stuff you don't want it to do, or will it actually circle back to you and ask questions? And so we built a benchmark around this, where basically we took a lot of really well-specified questions from SWEBench and made them underspecified and tested whether language models are actually able to tell that it's underspecified and ask the user for questions instead of going back and making a big mess of the code base.
So maybe we shift to you, Matt. You have been doing also exciting work at CMU and Swan AI on security for frontier models as well as agents. What are the 2 or 3 top takeaways that you want to share with our audience here?
Yeah. So I guess the main thing that comes to mind, or the sort of main thing that I would pay attention to if I'm somebody who wants to incorporate an agent into an application or deploy it, have it solve a problem for me, is while it is a piece of software, right? Like ultimately, it's instructions running on hardware. It's a fundamentally different kind of software than we're used to integrating into our workflows and into our code bases and so forth. And the reason for that is the underlying technology there that's driving the agent is this large language model, right? This very complex, kind of mysterious, in many ways black box artifact that has all sorts of interesting capabilities. It can do things in ways that traditional software, it would be extremely difficult or impossible to do, but it's doing it in a very different way. And kind of one of, from a security perspective, one of the most challenging, features or bugs or sort of modalities inside of these LLMs is, they're unable to kind of fundamentally distinguish the difference between, what's an instruction, something that I should do, an action I should perform, and what's data, right? So, we think of data as the information that's coming in that might in some ways influence, what the next action is, what the next instruction should be, or how it should be executed. But the lines get very blurry with LLMs, and that has big implications for agents. So if you think about what you want to do when you're going to deploy an agent to make sure that you're doing it securely and you sort of have a story for preventing bad actors from taking it off instructions or getting it to do something bad, you need to have a story for testing, and you need to have mitigations for the vulnerabilities and kind of like native security problems that are present there. And on the testing side, again, it's very different from the way that we think of testing traditional software, where I might have some unit tests, I might have some more involved tests, and I might use automated techniques like fuzzing or symbolic analysis. There are maybe variants of those that might make sense for testing an agent for security issues and vulnerabilities and failure cases. But ultimately, you do need kind of AI native solutions for doing that. And I think that they have to be adaptive. So one sort of holdover, I think, from working with AI in non-security related or non-adversarial settings is we're going to get a sense of how well this agent or this model performs for our tasks by running static benchmarks on it, right? And we're all familiar with looking at leaderboards and sort of seeing what models come out on top and making a decision about which to use based on those. It's very different for security in that a static benchmark for agentic security or AI security is going to saturate very quickly, right? The minute that it's out there, even if it's not directly ingested and used for training, things that look a lot like it will be. And at the end of the day, the way that a potential adversary is going to interact with your agentic deployment isn't statically, right? An attacker is going to come and use their ingenuity and their resources to adaptively probe and figure out sort of how the agent might respond and how they might get it to do their bidding on the fly that way. So in order to predict what failure modes might exist in an agent, I think adversarial adaptive testing, be it from an algorithm. There are lots of very interesting and I think practically useful research directions on algorithmic adversarial testing for agents and AI out there, or by bringing in teams of human red teamers. And one of the things that we're doing at Carnegie Mellon in partnership with NIST, National Institute for Standards and Technology, is working to develop kind of a science of AI red teaming. Because again, just like testing and vulnerabilities and everything is different with AI and agents, the same is true for red teamers. The skills that traditional cybersecurity red teamers have built up over the years don't always translate perfectly well to this new kind of setting. So we do need to learn more and sort of build that out as a science and an art that people can draw on. So testing is one side, then mitigations, safeguards, guardrails are the other. And I think that there is often a bit of confusion about like what constitutes a reasonable guardrail or mitigation for an agent. Certainly people who have worked with these are used to writing system prompts that lay out a set of rules and a set of do's and don'ts and sort of attempt to give the agent some sort of confines to work within. But what we've seen happen is at least the models that are being deployed today don't always stick to those rules perfectly well. And without too much effort, a reasonably determined attacker can usually find ways to get the model to just ignore that part of the system prompt and convince it that it's operating in some fictional scenario where it's okay to call this tool with these arguments and return the data, right? Because system override or something.
Aditya, data agents. Snowflake is very big on data agents as well, and you have been doing some pioneering work in this area with doc.etl and other projects that you're leading. Tell us a little bit about both some of the key research technology areas that you're pushing the frontiers of, and also what you're seeing in terms of community, open source adoption as you're pushing on these levers.
Yeah, so this is something that we started a couple of years ago. Started a lab centered around using LLMs to process large volumes of unstructured data. So that was a mandate, right? And we started by saying, okay, LLMs can help us process data, great. And then soon we realized that LLMs can help us determine how to process the data as well, not just process the data themselves. And so what we did was built an agentic query optimizer that, given a high-level task specification, go do this thing on a pile of documents, it'll figure out how to break it down into simpler tasks that can be actually executed more effectively by LLMs. So that was kind of the big aha moment for this tool that we built called doc.etl. It's gotten a reasonable amount of adoption in just analyzing large volumes of unstructured data in a, let's call it, declarative fashion, right? Think SQL for large piles of unstructured data. So that was the vision for doc.etl. And doc.etl has been used in a bunch of different contexts, ranging from forensic psychiatry to climate analysis to financial analysis. So the appetite is there, right? Really, people want to make sense of large volumes of unstructured data and use kind of agentic approaches to do it, because often when you come at a new data challenge, you don't know the right way to approach it, and an agent can help you fill the gap, right? And there are various gaps in the mix. There's a gap between the users and their use of LLMs. Often users don't know what the right prompt is for an LLM. There's a gap between the LLMs and the data themselves. Sometimes we don't know what the right framing of the LLM should be for making sense of the data. And there's also a gap between the users and the data, right? The users don't actually understand the data that they are operating on. So these are the three gaps that we are trying to bridge with doc.etl, and doc.etl has had a lot of adoption. But moving forward, I see this world where you have various different backends, right? So you have your relational backends, you have your semi-structured data backends, you have your unstructured data backends. You even have various types of SaaS applications, web search systems. And so ultimate data agents should kind of leverage the power of all of these backends, push computation to all of these backends, and kind of federate and combine information from these backends. I truly believe in this future, and I feel like we've already taken baby steps towards it. So I'm really excited about this space.
Yeah, so doc.etl is an open source project. You can go play with it. Matt, your work at Swan and CMU has also been super exciting. Like, one direction that I particularly found very exciting is this work on representation engineering that Don also has been involved with. And one of the cool things about representation engineering is that the work that Matt and collaborators have done lets us read the minds, if you will, of these big, massive, large language models and see how they are representing concepts like deception and hate and these kinds of concepts, and then build guardrails around them. And some of that work that Matt is doing with Swan is now getting used at OpenAI, Anthropic, Google DeepMind, and so on, which is huge impact at massive scale. And then Graham's work on All Hands, of course, is big open source project. You have like a 10-person team and 50,000 GitHub stars and hundreds of contributors. It's a true example of where something, a core research technology has got into a huge community and adoption in an area where arguably agents have had the most impact, which is coding agents. And then Don, like your work on virtue AI is something that is, I know a little bit less of, so maybe you can share a little and then we can open it up for audience questions.
Yeah, happy to share. So earlier I talked about when we built these AI applications and agents and so on, there's a broad spectrum of safety and security risks. So the question is, what can we do? How do we mitigate these risks? So essentially, there are different, several different parts. So one is that we need to have better risk assessments, evaluation, red teaming, and so on. And the other one is how do we actually defend against, protect the agent applications and so on. So virtual actually works across these different stages throughout the life cycle of the agent application development and so on. So first, for red teaming, for risk assessment, so this is built based on also our award-winning research. So together with other collaborators and so on, we developed, for example, the first comprehensive evaluation framework for trustworthiness of large language models that actually won the Best Paper Award at NeurIPS, the top deep learning conference, and also last year won the Best Scientific Cybersecurity Paper Awards of year 2024 given out by NSA. So NSA each year gives out one Best Paper Award. Last year was for our paper. And so essentially this allows us to actually develop these cutting-edge evaluation frameworks to evaluate the different types of safety, security risks of large language models. And since then, we have expanded to multi-model settings and also into the agent setting. We've developed various advanced red teaming technologies and frameworks for analyzing safety and security risks for agents as well. Including coding agents, web agents, and other types of agents, and so on. So that's on the red teaming side, and the other side is on the mitigation, how we can actually ensure that these agent applications can mitigate some of these safety and security risks, including guardrails for large language models, and again, we cover a broad range, also including multi-model, and also now we are developing like guardrails for agents as well. So it's broad ranging.
Awesome. Great. I think that was an excellent conversation. Thank you so much.